Okay, so this week we're going to talk about theoretical probability and experimental probability. So, this word, theoretical, this probability is what should happen in an experiment. So, if you toss a coin 100 times, you expect 50% to fall on heads. So, that's what should happen. But does it really happen? Let's see. The experimental probability is what actually happens after an experiment of many trials. So let's do a couple of examples here. So I'm not going to show you this one. I'm going to show you this one. So it says, so notice that we have a frequency table here. So it says the table below shows the results of rolling a standard die 50 times. So you have a die, you roll it 50 times. And then this is where 50 times got you to the result. So it fell on 1, 4 times, fell on 2, 10 times, fell on 3, 9 times, and so on. So these are the numbers in the die. These are the frequency that each, when you toss it, this is what happened. That's the frequency. There's a total of 50 times here. What is the theoretical probability of rolling a 4? So rolling a 4, in theory, it would be, well, there's 1 out of 6, right? So that would be, in theory, what could happen, what should happen. But when you roll it 50 times, then what is the experimental probability of rolling a 4? Compare this to the theoretical probability. So let's see how that looks. So rolling a 4, that would be 5 over 50, right? Because that's the times that you roll it. That's the times that you toss that die. So that 5 times it fell on 4. So that's 5 over 50, which is the same thing as 1 over 10, right? Because you are simplifying the equations. Now on this one, you have to know that then to compare it, well, this is definitely lower than that. So lower than expected, right? Because this fraction is smaller than this one. Okay, so that's kind of a comparison between the two. All right, let's do another one. So on this one, we have these spinner again. So the results of spinning the spinner to the left 75 times are shown. So this is a spinner, right? And then it fell on A 5 times, it fell on B 12 times. So when you roll it 75 times, when you spin it 75 times, this is the frequency that it fell on A, it fell on B, and so on. What is the theoretical probability of spinning a shaded letter? All right, so how many letters are shaded? That's 6, right? So that is 6 out of a total of 8. If you simplify this fraction, you divide by 2, that's 3 over 4, right? And then what is the experimental probability of spinning a shaded letter? Compare this to the theoretical probability. So we're doing the same thing here. So let's see. We have to add all the frequencies of all the shaded letters. So that's 5 plus 12 plus 10. These are all shaded. This is shaded, shaded, shaded. And then G is shaded, F is shaded, and E is shaded. So you add all those frequencies and you get 60. 60 over how many? 75, right? Because that's the times that you toss it. If you divide by here by 3, you get 20 over 25, and then you can divide by 5. So you divide by 5, so that's 4 over 5. So we know that this is higher than this. So higher than expected. Just because this fraction is bigger than this fraction. Okay? All right. So what happens when we're missing some of the numbers here? Let's find out using samples to predict what could happen. So it's part of this theoretical and experimental probability. So the table below shows the results of tossing a coin 100 times. So if you toss a coin, the frequency was you get 58 out of those 100 times you got heads, and then 42 out of those 100 times you got tails. So theoretical, how many heads would you expect to occur in 300 tosses? Well, what's the theoretical one? Well, one out of two faces of the coin is heads, right? Then that could be, well, we need to find how many heads would you expect to occur in 300. So how many heads would would you expect to occur in 300? Okay, and 300 tosses. Well, this is kind of like a proportion where you can use the butterfly method here, which you multiply the numbers and divide by the one with the variable. So that's 1 times 300 equals 2 times x, and then 300 equals 2x, and you divide by 2, and you get x equals 150. So 150, what does that mean? That means that you could expect um, heads to fall 150 times out of, so half of it, right? In those 300 tosses that you do. Now, let's work on the experimental one. What's actually happened? Let's see, because this is what actually happened, right? So based on the experiment, how many heads would you expect to occur in 300 tosses? So in the experiment, we got 58 out of 100, and then we get, so what will happen if you instead toss it 300? So we're predicting. Okay, so it looks similar. So this part of the theoretical, right? And this one is what happened in the experiment. So what would happen? How does it change? So you multiply the numbers and divide by the one with the letter. So that is 58 times 300 equals, and then divided by 100. That is 174. So that's what actually happened. This is what actually happened, okay, the experimental, based on these numbers. All right. Okay, let's do one more. This one here. Okay, so it says the table below shows the results of randomly selecting a letter from the word rhombus 80 times. So these are the letters, notice, and this is a frequency that you select randomly from when you select randomly 80 times. So theoretical, if a letter is randomly selected 500 times, how many vowels would you expect? Well, that is 2 vowels. Let's see how many. 1 and 2 out of 7 letters. 1, 2, 3, 4, 5, 6, 7. That's the theoretical probability. And then how many would you expect 500 times? So that would be x over 500, right? And then you do the butterfly again. 2 times 500 divided by the one with the variable 7. So that would be 2 times 500, that's 1,000 divided by 7, that is 142.8. Let's just put 143. X is approximately 143 times. So that's how many times you should expect, notice my language, to get a vowel when you toss it 500 times. All right, so based on the experiment, if a letter is randomly selected 500 times, how many vowels would you expect? So there are 6 plus 18 vowels. That's 24 out of how many total letters? There are 80 times, right? That's 80 times. That's what actually happened. In 80 times, 24, because this plus this was that's the frequency that it fell on those vowels. So what actually happened? Well, let's see how many out of 500. Do the same thing, multiply and divide by 80. So that is 24 times 500 equals divided by 8, 150. This is what actually happened. Okay. All right, students, I hope this helps.